We're here at ISE 2026 in the booth of Ada Imaging, and today I'm going to show you a bidirectional FieldCast multiplexer that can send 6 SDI channels from A to B, 2 SDI channels from B to A, plus Ethernet, all over one fiber optic core. Let me first tell you that this is a custom set, since by default FieldCast multiplexers are unidirectional with 4, 8, or 16 channels going from A to B. The set I'm showing here today is called FieldCast Mux Demux Two 12G Plus 6i20. Now, why would you want such a configuration? You might, for instance, want to send the SDI signals of 4 PTZ cameras and 2 handheld cameras all the way to the switcher in the control room, which could be located miles and miles away from the cameras. But you also want the program output of the switcher to be sent back to those 2 camera operators who are operating the handheld cameras. So you want a return signal. In this situation, a bidirectional FieldCast multiplexer is the ideal solution. Now I'll show you how the system works with 6 in and 2 out. This is the MUX. The MUX is typically placed in a location near the cameras. Channel 1 through 6 are the input channels, and you can see here SDI in for channel 1 through 6. The top row here is just a loop through of the first row. Channel 7 and 8 are the output channels on the MUX. You can see here SDI out for channel 7 and 8, which also come with a dual output. Channel 1 receives a 12G SDI signal from this camera, the Ada PTZ 4K 12G, which is currently Ada's biggest PTZ camera on the market. Channel 2 receives a 3G SDI signal from that same camera. And what's nice about FieldCast multiplexers is that they automatically detect whether it's a 12G or a 3G signal. The Ethernet port here is connected to a hub where you can connect all the Ethernet ports of your different cameras. This is the fiber port where I connect the fiber optic cable from the MUX to the Demux. As you can see here, we're only using one fiber optic core to transmit all video signals plus the control data over Ethernet. That means the second core here is unoccupied, and it can be used for other purposes. This port is called the upgrade port, and I'll come back to it in a second. At the other side of the cable, which can be miles and miles away from the cameras, we have the Demux, which is typically placed in the control room. The Demux is the twin brother of the MUX, and is in fact the other side of the same channel. So input channels 1 to 6 on the MUX correspond to output channels 1 to 6 on the Demux. And output channels 7 and 8 on the MUX correspond to input channels 7 and 8 on the Demux. Earlier I mentioned that this is a 6i20 system because it has 6 input channels on the MUX and 2 output channels on the MUX. But on the Demux, it has 6 output channels and 2 input channels. So you could also call it a 6.0 2i system. It all depends what you take as your point of reference, the MUX or the Demux. On the Demux side, channel 1 and 2 are connected to these monitors. This is the output of channel 1, which is the 12G SDI signal. And this is the output of channel 2, which is the 3G SDI signal. The Ethernet port on the Demux is connected to a camera controller, where I can control all my different cameras. So here is the output of the 12G signal. And here is the output of the 3G signal. Now we're going to set up the return signal. Since we don't have a switcher right now with a program output, we're using the dual output of SDI out on channel 2 on the Demux. And we're connecting that back to the SDI in of channel 7. We could also take channel 8 because, as I said before, we have 2 input channels on the Demux side. The SDI in of channel 7 on the Demux side travels all the way back over that same fiber optic core to the SDI out of channel 7 on the Mux side. On the Mux side, we have connected the output of channel 7 to this little monitor right here. So if I zoom in from my control room here on the Demux side, you should see the same result on your monitor on the Mux side. This is how you set up your return signal. Now I'm going to tell you a little bit more about the upgrade port. The beauty of this system is that all this information travels over just one fiber optic core. That means that there's another core available for a different purpose. One way in which you can use this available port is by upgrading your system to more channels. That's why we call this the upgrade port, or the UPG port. The upgrade port allows you to add more channels without replacing your existing hardware. You can simply connect the upgrade port of your existing Mux-Demux pair to the COM port of a secondary Mux-Demux pair, up to 16 channels of SDI video and full duplex 1 gigabit Ethernet. When connected, the cascaded system will still run all information over one fiber optic core. Cascaded systems can easily be split up into two independent Mux-Demux pairs and then be recascaded as needed, making them ideal for environments with staged or modular network builds. It's also budget friendly because you can start with the channels you need today and then scale up as demand grows. FieldCast multiplexers are unidirectional by default when it comes to the transmission of SDI signals, but we can build them bidirectionally on request. So if you let us know how many channels you want from A to B and from B to A, we can custom build that bidirectional multiplexer set for you. That was it. I hope this video was useful, and I'll see you next time.